All right, scholars, good morning. Ladies and gentlemen, welcome to Activity for Processing 1.1. This is going to be the first lesson from Unit 1. There we go. All right, so a quick introduction to how this thing works. So we're going to notice here at the beginning, we have Unit 1. Allow me to go back a bit there. Unit 1, Lesson 1. And then within Lesson 1, you have your Activity 1, Activity 2, Activity 3, and what I would feel should be read at the end of every lesson, the lesson summary. So that's usually the format. You have your lesson, the name of the lesson, and then one or two activities or three activities rather, and then followed by this really important summary here. So at the end of each lesson, I would definitely encourage you to read the summary and see, do you understand every piece of it? If not, I would then kind of rewind to your notes and see if you can kind of figure it out or ask questions. See what part of the lesson summary do you or do you not understand. After the summary, then we hop into some practice problems. They always have the practice problems afterward there. And then that's it. So let's go ahead and jump into it. So today's cool down is going to ask you to generate some sequences using terms. So let's get into our example 1. Suppose that you are given the numbers 1 and 2, and they ask you to predict the next 3 terms of the sequence. Sequence is the name we're going to give to our pattern or list of numbers. Term is the name we're going to give to each of the numbers within the sequence. So you can say 1 is the first term, 2 is the second term, and whatever goes here, here, and here are the third, fourth, fifth, and then you can go on infinity, 6, 7, so on, terms. Okay. So in order to fill out the next term, it's up to you how you wish to do it, but it's asking you to do it 2 different ways, right? So there are a few different ways in which we can go about this. But it all starts here with the 4 properties of multiplication. Okay? Our sequences have to obey one of these 4 because those are the only 4 that are applicable in this environment. So we can either multiply, divide, subtract, or add. Now, for the sake of today's sequences, you're going to notice that it's increasing from the first term to the second term. So the only 2 operations out of these 4 that cause a sequence to grow are multiplication and addition. So if you multiply or add to your money, you're going to end up with a bigger pile of money at the end of the operation being applied to your original money amount. For instance, if you had $1 and you multiplied it by 2, then now you have $2. You doubled your money. If you had $1, but then you added $1, then you have 2. Then this time you added $1 and you wound up with 2. Both of these would increase the original term to get to the second term. And then you follow this behavior as you list the following terms. I'll show you how to do that in a moment. I'm just going over the operations of mathematics and how they apply to sequences and the list of terms. Next, we have division and subtraction. I'm going to use the word decay. Why not? Decay means that the value is going to actually be going down. So I'll go ahead and show you some decay over here. What if I had like $100 and then I divided it by 2 that gives me 50. Or what if I had $100 and I subtracted 50? Well, now I have 50. Regardless of whether it's division or subtraction, we can see that the original $100 after the operation was conducted led us to a smaller amount than originally we had. So once again, we have two operations which cause growth and two operations which cause decay when using whole numbers. I'm going to throw that last part in there because things get interesting when you start multiplying by fractions or dividing by fractions. But that's for another time. But for the most part, when you do these operations with whole numbers, we can safely assume that these properties hold true. I feel like I want to do one fraction example right now. Just to kind of, in case you're wondering, like, well, how would a fraction, if you multiply, you're saying over here, it causes it to grow. How would it cause it to, well, let me take this example here and actually show you how multiplication can actually cause so if you punch these two values and multiply them on a calculator, or you can do it the long way where you actually solve it out. Either who, 100 times 1/2 gives you 50. You see, this time multiplication did lead us to a smaller number, but that's because we're messing with a fraction this time, a ratio. So for the most part, you can hold these laws to be true, but then they do get a little spicy, to say the least, when we start using fractions. But right now, we're not going to play with fractions just yet, right? This is the first lesson. We just want to practice building sequences. It's more information than you probably wanted, but I am not one to hold myself back from throwing a little extra info out there. At the very least, it leaves you with a little confusion, a little wonder. You want to know some more, and that's good. It builds a curiosity, and curiosity is going to be your best friend in this class. Okay, let's get to it then. So we had a long-winded discussion about the four operations of mathematics and the behavior they exhibit when placed on a list of terms which create a sequence. Well, let's get into it. So the cooldown's going to ask you to list the next three terms and describe the operation of mathematics that caused that. So we could think of it that we added one. I believe I mentioned this earlier. So 1 + 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. Excellent. Now, another way we could have done this, instead of addition, we could have used multiplication. So this was times 2. We doubled it, right? Times 2. Let me list a few more out here. I'm going to use a line here so you can know which ones were the original terms and then which ones were the ones that were fabricated here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I think I did that correctly, but hey, I make mistakes. All right, so we can easily say, if I called you out, like, hey, how did you build your sequence, and what are your terms? How were they born? Well, you would say that each term is one more than the one before it. 4 is one more than 3. 5 is one more than 4. My sequence of terms was built by adding 1 to each term. Down here on the red sequence, we can say that I multiplied to get to the next term of the sequence. So 16 is 2 times greater than 8. 8 is 2 times greater than the previous term, which was 4. Right? So many ways you can go about describing it, but that's how I would go about it. All right, so that's example 1 there. Let's go ahead and hop into example 2. All right, let's go ahead and look at two numbers. I'm going to ask you to try that. Remember, you can, oh wait, sorry. You can pause the video right now. Try to build two different types of sequences here and here using two different operations of mathematics. Try that out. So first you have to ask yourself, am I seeing growth or am I seeing decay? And then proceed. All right, so can now unpause the video or pause. Remember, I'm in real time, you're not. So you can always pause and see, all right, let me see if I can build this in my notes. Because you always want to have your notes out for a video, right? So build your sequence while the video is paused and hit unpause, and let's see if we both can come to a consensus and agreement, right? All right, so the first one, I think I can use +4 to go from one term to the next. And I will use this value here, this increase of 4 units to go to my next term. So 6 plus 4 is 10. That's my third term. 10 plus 4 is 14. That's my fourth term. And now I have my fifth term there. All right, so another operation I could have used here was the multiplication. So 2 times 3 gives me 6, which is the second term of my sequence. And now if I wish to get the remaining terms, I would multiply by 3, because each term is 3 times greater than the term before it. So here 18 is 3 times greater than 6. 54 is 3 times greater than 18. And 162 is 3 times greater than 54. All right, there we go. All right, so I'm going to hop into example 3. I'm going to give you the first 2 numbers of the sequence. Then at that point, pause the video, see if you can build the sequences by yourself, and then hit play once again to see if we come to the same conclusion there. All right, so here you go. So right now, after I'm done drawing this, you would hit pause button, hit the pause button, boop. Try it in your notebook, see if you can get the same answer. Annotate too, right on the side, like what did you do? Write some notes for yourself, right? When you look back at these notes, if you just see random numbers with no notes and you cannot tell what you did, you're gonna thank yourself in the future if you did do notes, right? Little notes on the side. Either way, let's get to it. So here, one option I have is to add 15. So 5 plus 15 is 20. Let's see if I can do this here. 35, 50, and 65. All right, so I added 15 each time. So the term that I have is 15 greater than the term before it. Awesome. This last one here, I'm gonna use my other property there of multiplication. So here I believe it's times 4. I use this little symbol for multiplication in case you haven't seen it before. And if I didn't mention it earlier, my apologies. So times 4, times 4, times 4, times 4. All right, if I made a mistake or something in here, don't let that take away from what I'm trying to say here. But thank you guys for taking a look at sequences and how to go from one term to the next by creating an amount that gets you from term 1 to term 2, from term 2 to term 3, so on and so forth. Just one question here. Just one question for thinking. Not that we're going to go over it or anything, but just a curiosity. I wonder how this would look if I had to go to the left. Huh. What would that look like if I had to go to the left? I went to the right. Just a question. I'm not going to answer, but just a little thought. And I'll leave you with that. Thank you guys. Good luck.